Imagine a future where humans are not confined to the bounds of Earth, but instead have established thriving, sustainable colonies among the stars. The idea of designing a space habitat is no longer a figment of science fiction. It is an extraordinary challenge and opportunity that many scientists and engineers are tackling today. Join us as we explore the intricate process and innovative ideas behind building a sustainable off-Earth colony. The journey begins with understanding the fundamental requirements of sustaining human life in the vastness of space. The primary consideration is the provision of adequate shelter. A space habitat must protect its inhabitants from the harsh environments of space, extreme temperatures, cosmic radiation, and the microgravity conditions that challenge our conventional building methods. To ensure survival, the habitats must be constructed with materials capable of withstanding these challenges. Advanced materials like reinforced composites and self-healing metals are being explored, engineered to offer robust protection and longevity. Now, let's delve into the concept of a closed-loop life support system. In space, every resource is precious, and recycling is not just preferred, but essential. A sustainable habitat relies on recycling water and air to maintain a habitable environment. The bioregenerative life support system is at the forefront of these efforts. By integrating biological components such as algae and plants, these systems not only produce oxygen, but also help with waste processing and food production, creating a balanced ecological cycle. Such innovation not only aids sustainability, but also enriches the quality of life for dwellers by situating them amidst living greenery. Energy generation is the next critical aspect we must address. Solar power presents a viable solution, capitalizing on the abundant energy radiating from the sun. Space habitats could employ advanced solar panels or orbiting solar power stations to harness and supply energy efficiently. The design of these systems must be resilient and adaptable, ensuring a consistent energy supply even when direct sunlight is not available. Consideration of supplementary energy sources, like nuclear fission, can further enhance energy reliability, offering a strong foundation for future expansions. A flourishing space habitat also requires a dependable food supply. Traditional agriculture is inefficient for space. Therefore, hydroponic and aeroponic systems are gaining interest. These soil-free farming techniques minimize space and resources while maximizing yield, enabling colonies to cultivate a diverse array of crops. This not only provides sustenance, but also promotes mental well-being by involving inhabitants in the nurturing of life. Integrating scientific advances like genetic modifications can enable crops to grow under modified conditions, increasing resilience and productivity. Furthermore, maintaining the physical and mental health of colonists is paramount. Microgravity affects bone density and muscle mass, requiring diligent exercise routines and innovative equipment to mitigate its effects. Mental health is equally critical. The isolation of space presents unique challenges that mirror those we face during prolonged stays on submarines or Antarctic expeditions. Designing communal spaces that encourage social interaction and using virtual reality to create immersive experiences can alleviate feelings of detachment and boredom. Now, let us elaborate on the societal structures that would underpin such a community. Establishing governance and legal systems, prescribing rights and responsibilities, and ensuring fair distribution of resources are vital to a harmonious society. Lessons from historical migrations and space missions inform us that adaptability, cooperation, and mutual respect are foundational elements of successful communities. Cultivating a sense of belonging and shared purpose will be crucial in overcoming interpersonal challenges. In conclusion, designing a space habitat involves an amalgamation of cutting-edge technology, profound environmental understanding, international collaboration, and an indomitable human spirit. These habitats hold the promise of expanding human presence beyond Earth, inspiring generations to come with the possibility of life amongst the stars. As we strive to build a sustainable off-Earth colony, we not only advance space exploration but also gain insights that could transform how we live sustainably on Earth. The lessons learned from these cosmic endeavors might just hold the key to preserving our blue planet.